So let's transform a graph by using several transformations that we have. So we have a function f of x equals 2 times x plus 3 squared minus 1. So the hardest part might be just simply identifying what is its base graph. What does this all boil down to? Basically, what's the basic version of this graph? And if you're able to see that, it's an x squared. So if I can draw its basic x squared graph, and then I can go ahead and graph the rest of it or find its final version through some transformations. I see that I have a horizontal shifting here. I see that I have a stretching here, and I see that I got a vertical shift there. So this graph can be transformed using 3 different aspects to get its final version. So let's go ahead and transition it first by the x minus 3. So that takes every point of the graph and moves it over 3 units. So now I have this one, which is basically x plus 3. This one was x plus squared, or x squared, x plus 3 squared. Shifted the entire x squared graph 3 units to the left. The next part I want to look at is, what does this 2 do? What does that 2 do outside of this x squared? Since it's outside, we know that it's a vertical shift. If it was inside, it would be a horizontal shift. But since it's outside of x squared, it's not being squared itself. We know that it's a vertical stretch. Sorry, vertical stretch, not vertical shift. So every point on this graph is really just being stretched. Two units. And it's not changing its shape. It's just stretching it out. And then lastly, this -1. That's a vertical shift. It takes the entire graph and shifts it down 1 unit. So there becomes my vertex, and then I just have this entire graph shifted down 1 unit. Now I hope when you watch this, if you're looking at this video just now, you see 3 different lines. But if you stop, rewind, play, you can see how the first line the first graph got shifted to the left 3 units. It got stretched twice as much, and it came down 1 unit. And that was its basic x squared graph, shifted and transformed using those other components that we have there.